need to time it better so that the song actually ends just when I dial in or like open the mic. Hello everyone, good evening or good morning, depending on what time zone you're in, or I don't know, good very late night, I guess. So, today's moderator is going to be Foxtrot Charlie. You can see his nickname here. And we are going to continue playing with making an assembler or emulator or something like that for GW Basic. As in not the language, but the actual interpreter, the Microsoft interpreter/editor that they released. This is the fourth episode, so basically we are at the state where we have first level of parsing, we are already tokenizing properly, and we started working on the second level of parsing, which is basically, let's maybe do it like this, which is basically making sense of the tokens. And last time I believe we finished with macros. We basically get to the level of macros, and then I was like, yeah, I just don't have a good idea how to deal with macros, so let's just finish the stream for today. We run out of time. Let's like look at the time we have to finish, yeah, basically. But I have some ideas, so we can play with them, and we can finish the macros, and then having that, we should be able to have enough to either build an assembler or an emulator out of that, or like and by assembler I do mean an assembler and a linker. And yeah, it's, well, we're going to do one or the other, but before we get there we still have to parse everything so that we have basically a list of instructions per, or like list of labels and instructions per I guess per compilation module. By compilation module, I mean here like a file, an assembly.asm file, which also includes all the files which are being included and imported and whatever you want to call it. Cool. So before we get there, however, the usual 15 minutes of let me like tell you about random stuff and answer the questions, and then we'll get to today's topic. Again, today's moderator is Foxtrot Charlie. You can see his nickname here. If you have any questions, and you are on our chat, one of our chats, we have 3 chats, as you know. We do have YouTube chat, obviously. We do have Discord chat, and we do have IRC. So if you are on one of our chats live, you can ask questions either directly using exclamation mark and Q, and then the question. You can see other people do it on the chat already, or you can write to Foxtrot Charlie, who will then add it to my question panel, and yeah, I will try to answer the questions either at the beginning or at the end of the stream usually. Cool. Now let's switch to some random stuff I have prepared as usual. Okay, let's start with this one. This is, well, Foxtrot's website, so foxtrotlabs.cc. And yeah, take a look, visit our moderator's website. It's absolutely amazing. Probably the best site on the internet. 9 out of 10 dentists agree. And this is something that was supposed to be online in some form or the other ages ago. This is basically a temporary website like ginveil.live. I'm saying temporary because it doesn't have everything I want there to be. I'm not sure we'll ever get there, but this is a website where there is a calendar of live streams. This is the hacking live stream, which is in English. If you speak Polish, there is this like button here to switch it to Polish live streams and Polish calendar. There's our team. It will be a little bit more filled as soon as they actually do pull requests with the avatars and stuff. And there is the FAQ. So if you have any questions which are on the FAQ list, you will be sent to the FAQ list. We basically try to add, well, a lot of typical questions there. There's also a Polish version if you speak Polish. And yeah, there we are. Cool, I'll give you a link. It's, well, ginveil.live. Little magic there, I guess. I just need to switch here. Here we go. Okay. So that's it now. Oh yeah, I don't know. We are reaching almost the 32K goal of, like, you know, 2 to the power of 15. That's nice limit to, well, maybe not limit, nice number to celebrate, as we do speak binary here, right? So we are very close there. I'm really happy, and I guess what I'm not telling you is that I kind of miss the thanking you for the 30,000 subscribers, so I'm going to do it now. Thank you for being here with me and yeah, watching my live streams. Then we have, the call for papers for a conference I organize is going to be, it's a Polish conference, it's this year through the internet, but we have some English talks there as well. So if you would like to present something, the call for papers is still open for the code and for security and hacking. We have like two different tracks, basically the security and hacking track and the code, like general programming track. So if you want to speak on a conference, I'll send you the links as well. So here we go, this is the first link, and this is the second link. Cool, and I'm not going to close the browser. Let me open the GW Basic. Maybe let's open the GW Basic on GitHub. I'll send you a link as well in case you missed it. I'm wondering if I was supposed to say something. Oh yeah, the Rust conference. Not always. This is the first time I actually forgot it. rustydays.org. It's a virtual webference with a hackathon about Rust. If you like Rust, like it's in a couple of days. So if you like Rust, like check it out. It's done by some people from Wrocław, from Poland, and they're like, the speakers are international pretty much. So it's, you know, it's not just a local event, it's like a larger event. There is a full agenda, we can take a look. Yeah, like check it out. There's like quite a lot of talks actually, and there's a hackathon. Hackathons are always cool. So, going back to ginveil.live, in the FAQ, if you ask like, hey Ginveil, what about Rust? See, we have now this on our FAQ. Ha! So yeah, I don't know, we should have made this FAQ like ages ago. I know that a lot of actual, you know, professional live streamers have it, but I'm kinda slow, as you know. Cool, let's do questions. Let's do questions for about 8 minutes, and then we switch to our topic today, which is again making an assembler, or continuing making an assembler for GW Basic, for the GW Basic source code, not for the GW Basic language. How do we do showing of the questions? Here, the questions will be here. Let me move the mic a little bit. Okay, with Ido writes, with all the new versions of C++, could it be eventually safe as Rust? No, because the memory model is completely different. That's one thing. The second thing, I have no idea is if Rust is fully defined, but C++ is not fully defined. It means that there's some, like you can write code which, like the standard says, I have no idea what to do with this code. The syntax is valid, I can compile it, but no idea. No idea what this code will do, what effects will it have, what side effects will it have. So yeah, that's undefined behavior, and undefined behavior is one of the reasons why C++ is super fast, because the compiler does not have to support weird code. It does not have to, it just like trusts the programmers that the code will never reach a weird state. And I'm not sure how Rust goes about it, if Rust defines everything or if there are some places which are undefined behaviors as well. The undefined behaviors are, you know, a good thing on one side because speed, right? On the other side, every security vulnerability, every low-level security vulnerability is an undefined behavior. So pros and cons. If you fully define a language, then you might still have vulnerabilities, but probably less so. So yeah, I don't think C++ can be as safe as Rust, but we'll see. And well, maybe in C++ 30 or 38, they make a drastic shift from like totally throw out the pointers and integer overflows and whatever from the standard and say, yeah, C++ is now like fully defined with garbage collector and whatnot, and yeah, that will be it. But it will lose a lot of speed, which in 2038 maybe might not be a problem. Okay, Eridanus Supervoid writes, "Hi, would you recommend emulator-based emulation for kernel fuzzing, especially drivers? If yes, what is the typical must be emulated apart from what typically must be emulated apart from the CPU?" I know that some people use this, and I know they find a lot of bugs. Because at the end of the day, this is a slow approach, but at the end of the day, if you have a good fuzzer and you fuzz stuff which has not been previously fuzzed, then you will find bugs even with a slow fuzzer. A slow fuzzer will not cover as much walking distance, basically as much distance as a fast fuzzer, but at the end of the day, yeah, is one of the things people do, and that actually works. What needs to be emulated? Just start with a full system emulator, like start with QEMU or like Box or something like that, and figure out how to figure out basically how to set up the fuzzer, how to get bugs reported from the emulator to your fuzzer, because that's not trivial, and how to detect bugs in the first place, and then see if you can like lighten up the system. Maybe you have a full-blown Ubuntu server, and maybe instead you can use like some really thin distro which doesn't really have anything in the background running. Same with Windows, you can cut out a lot of stuff in Windows. And then start turning off devices, which devices you don't need. Maybe there is like the emulator can emulate a different kind of, I don't know, chipset or like IDE controller or whatnot, which is actually faster. It's like stupid, you cannot do everything, but you can actually, your fuzzer will be faster. So try it. And yeah, what typically needs to be emulated apart from the CPU, but it really depends on the kernel you are fuzzing. Usually the CPU is the most important thing, including the memory controllers, obviously. Do you need anything more? Technically, I don't think you need anything more apart from a mechanism, like some storage. You need some storage. Be it like even just I don't know, flash card, SD card emulator or something like that. But you will need that just for the kernel to load your stuff from, your samples you want to fuzz. You do not need the network card, you do not need most of like PCI bus or anything like that. You might want to have some serial for debugging, but that's about it, I think. You don't need too much stuff. Yet again, take a look at QEMU, and take a look also not only at x86, take a look at other architectures, because maybe you can fuzz other architectures and it will be actually better. And that will give you better results for fuzzing because of differences between x86 and different architecture. And it will be actually faster to run an emulator for that architecture than x86. What's on your t-shirt? There are only two hard things in computer science. That's cache invalidation, that's naming things, that's asynchronous callbacks, and that's off by one errors. Yeah, this is an old joke, I guess, in programming and security, so I got a t-shirt with it. When will be OS dev? This is a Polish question. We have this question in the Polish FAQ because we never had an OS development series on the English side, so there are no reasons for there to be questions about it. The typical answer is it will be after or before ray tracing. We still have a minute or two. So, from Arkanoid, is watching write-ups of challenges or CTFs when stuck hard bad? No, quite the opposite. This is something I guess I started writing a blog post about it, how to learn CTFs, basically. I need to finish it. My typical answer, which I guess we need to add to FAQ, is at the beginning it's fine to do it. Later on you start doing so at the beginning you read a lot of write-ups and you watch a lot of write-ups and just skim through them, like to get some knowledge into your head, but basically a knowledge of a type where to find it if I need it, not the knowledge of a type I understand it by heart now. So after that, grab a write-up, grab a challenge, and repeat the steps which are in the write-up to basically learn what has been done, which tools have been used, how they were used, and try to learn as much as possible about everything there, about the tools used, about the tricks used, about the techniques, about the process. And then do it again with another chunk, another. Then start putting the write-up aside. Start using it only, looking at it only if you're stuck. And then like start looking at it only when you're stuck for a week, for example. Week isn't a long time. Like that's okay to be stuck at the challenge for a week. And then like totally put it aside and just continue until you're like super stuck really, and you say, yeah, if to solve this challenge I just need to look up what tricks they're using because it seems to be a piece of knowledge I'm just missing. So do that. It's typical after the CTF, if you play the CTF, like an actual competition, actual tournament, and if you are on the IRC channel after the CTF, people from major CTF teams and all CTF teams are asking, how do you solve this task? Because I couldn't solve this task, I was close, I couldn't finalize it, I couldn't get the flag. How do I solve it? People are sharing write-ups, just talking about each task to learn. And it's totally fine if you didn't solve a task on a competition to learn how to do it. You do not have to force yourself through the task to the end. Just learn how to do it. What were you missing? Usually you are missing like a super small piece and like you're like, okay, I just like read this line on the channel. You're like, clap, 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 flag. And you're like, yeah, I should have done it like 15 minutes ago. So you would win or something. Yeah, that happened a lot of time. So yeah, it's not bad. It's just like, do not rely on it. Do not get addicted to using a write-up. Put it aside, like detach from it at some point, but do not be afraid to grab it again if you just need to learn a trick or two, or like you miss a piece of knowledge. Okay, ever thought of creating a ranked KrzaQ site? Currently no good KrzaQ sites has ranking systems. Good question, maybe. The answer is maybe. Yeah, let's leave it there, maybe. 2021 is an interesting year for me. It will be an interesting year, so yeah, let's leave it at that for now. Okay, I'm going to scan the questions really fast now and we'll jump to the topic of today. Okay. Okay, let's finish the questions. Eridanus says, do you think that the world should stop writing new projects in C++ due to security reasons and switch to Rust? It's not... okay, it's not always possible. Like in a perfect world, that would be great for new projects. It's not always possible. Because reasons, like for example, you do not have enough trained Rust programmers, and retraining your like seasoned C++ developers to Rust is kinda a waste of money and waste of time. So sometimes it's okay. Sometimes like, yeah, you cannot write something 100% securely, just put it in a sandbox, right? It's not great. You can escape some sandbox, but the level drastically rises, especially if that's a server-side thing, like a server-side custom installation. That's absolutely totally different than a client application, which is sandboxed. It's much harder. Due to obscurity usually, but still. Yeah, so I would love to like folks to use more languages which are safe, not necessarily Rust, like Rust, Go, Python, even JavaScript, right? JavaScript doesn't have like memory vulnerabilities, so that it has different issues, but it doesn't have them. So yeah, and like there will still be need for having parts of a code in C or C++, but if it's like not a lot of code, then that would be great. So yeah, I do agree that yeah, like it would be great if we could limit the amount of C++ code is going to be written in the future, but it's, you know, decisions of companies and other people. So Foxtrot Charlie, have you ever been offended by the duration of your CTF task solution? Like somebody solves it too fast? No, I would be amazed actually. Like if somebody solves it fast, then and I say yeah, it would take for me 2 hours to solve it, knowing the solution, and somebody solves it in an hour. I'm like, wow. Unless I did a mistake, right? If I made a mistake that and there was a how it's called, like an unintended solution, then, well, yeah, happens. But absolutely happens on the CTF. That's why we have dynamic scoring now, so that even if there is an unintended solution and everyone goes for it, the task will balance itself out. So, no, I don't think I would be offended. I might be laughing at myself for like not spotting an obvious solution, or like be amazed at the player who actually solved it due to how good they are. But offended, no. Okay, do you have to pay for these conferences in the sense of admissions? Yes, and okay, yes for the Poning one. Not sure about the Rusty days. Check it. I honestly did not check for the Rusty days if you have to pay for it. I think no, but don't take my word. Like, double check it. For Poning, yeah, it's a paid conference. Okay, I saw some security researcher streams. He writes emulators and JIT for fuzzing. Yeah, Brandon, right? Folk. He's amazing, absolutely amazing. Outperforms AFL in a factor of, and it scales, yeah. So it doesn't seem... okay, what Brandon writes, it's absolutely amazing, and he knows what he's doing. If you want to go like with a specialized custom emulator, that's a different thing. Especially if you're using like, you know, AVX and other stuff. So yeah, then absolutely do it. Do note that Brandon is like, he's the person who got a Pony Award for his work. He's absolutely amazing. If you haven't seen Brandon Folk's live streams, do check them out. He's, again, absolutely amazing. I fully recommend it. He does magic, and that's just great. Yeah, if you can go that road, if you have enough knowledge to do that, absolutely do it. If you don't, but you want to try, absolutely do it. You will learn a lot. I was thinking of some other researchers, actually, also Pony Award winners who are using emulators, but the slow ones. Let me send you a link. Okay. Tom Folk. Is Gazmo? Wait, let me do something like this. Gamozo Labs. Okay. Is it this one? How to find him on YouTube? He's here on Twitter. Brandon Falk, not Falk, Falk, sorry, my bad. Yeah, like, check out his Twitter. Here we go. Again, this guy is absolutely amazing. So, yeah, check him out. Okay. I'm reading the next question from Chris. Why are there two FAQs? The language switcher isn't very obvious. Yeah, I think I'm going to change the PLEN to flags. But, well, it's the same FAQ. It just like two questions are missing about ray tracing and about OSDEF. Everything else is literally the same. It was, we've written the Polish version, send it to a translator, and yeah. So I guess this is a good moment to thank the person who made the website initially, that was Jakub, to our translator who translated the FAQ, and Masakra who set everything up, basically. I just did some minor tweaks with HTML and deploying at the end. So thank you everyone who was working there. Unless Chris, you mean something more, but like there should be a link to, I don't know, FAQ Polish, FAQ English or something. Okay, let's stop here and switch to the topic of today. I will answer the remaining questions later on. Maybe in a break, maybe at the end of the stream, but I will get back to them. Unless we... Yeah, there has been one live stream where I didn't answer all the questions, and that was last week, the Polish one, because there was 174 questions, I believe, and I ran out of time. Like, we were like half an hour over, and the questions had no end. So that was like literally the first time I couldn't answer all the questions. Thankfully, there are only 3 more questions, so let's just do them afterwards. Cool, so we are going to today's code, which is, this is our beautiful parser that I put it on GitHub. If I didn't, then just like yell at me at our Discord, and I will put it on GitHub later on. What it does, it basically does this. Let's run it, yeah. And it outputs some stuff. So this stuff is basically the tokens we are trying to parse and make sense of. As in, what we are doing right now is we are grabbing the tokens. And this is a great moment to show a piece of code. Here we go. Here's this. Then let's open this. Yeah, and we have this, for example, like these are what, 4 tokens, right? It's 5 tokens actually, according to how we do it. This is this like add string, bx string, this comma here, the cx string, and then there is the new line, like the enter, right? Token, which we also treat as a token for some reasons. For like, I figured that makes sense to some extent. I'm absolutely ignoring the comments because the comments are absolutely being removed. So comments do not play a role. And yeah, and then this was the first level, the first layer. And after I had that, for each file, I had a list of the tokens. What we started to do is we started to basically combine them. Like we had this add bx, cx, and a comma, and I said, hey, that's an assembly instruction with parameters. So now it's like one node. It's just one node, one full node, and yeah, like this is a full node, which is assembly instruction and 2 parameters. And this is what we need to finish today, basically merging the tokens into expressions. These aren't really expressions in a full sense of it, but that's fine. So, I wanted to thank one person here. I didn't notice that this is not an x86 instruction. Move RI and send for DC noticed it, so thank you for noticing it. And I removed it from this list from the last live stream. Here we go. So I think this should now be our instructions, basically. And let's see what's being outputted. Okay, let's do less. Let's put it through less. Okay, so S token is a simple token, and then we have the expressions. So we have type expression dot something, the name is dot radix, and these are the arguments for it, which is, sorry, that's kind of weird. It shouldn't look like this, or should it look like this? No, it's fine, okay. Yeah, like, it's actually one argument, and this is the type of argument. It's a literal, and 8. Literal is basically like, you know, just 8. Directly 8. It's not like x, where x is equal 8, it's just 8. And that 8 is called a literal. I'm sorry, my English doesn't exist today. Okay, yeah, so what works, what doesn't work, that's a good question. Let's go at the end and see what doesn't work. Which file are we parsing, by the way? This is something I would like to check. We are parsing only... I would like to only parse this. Print, parse, and break. Okay. Okay, so we are parsing this GW main file. Why are we having some tokens at the top? I don't know yet. This is probably the token which I have no idea what to do with. And we get to the one thing I'm missing here, and as I told you on the previous live streams as well, it's going to bite me later, but I'm missing any information about where did I found this expression, like which line was it in, which file was it in. Okay, we have a jump instruction, that's an assembly instruction, and we're jumping to an identifier endcon, which is fine. So let's look where this is basically in the file, so we can know how, oh, it's not, wrong file, nothing happened. It's main here we go. Okay, so yeah, we have this jump here. Here's the place basically where we are, and before that there is this and C and J, and this is a label. So this is as an expression of a type label, and we have it here. Perfect. So this is actually correctly parsed. You can see we do not have this token. We have a colon here. We do not have this colon because this is a token, which is it just is there to tell us that, hey, this is an identifier, a label. And we know it's a label, so now we can remove it and it's no longer here. We just get to the next expression. And we finished here, which means that, yeah, we have this dermac EFN, and I have no idea what a dermac EFN is. And yeah, and it's a macro. That's all we figured out last time. So let's look for this macro. Where is it defined? Is it defined in this file? I don't think it's defined in this file. It's probably defined somewhere else. And if it's defined somewhere else, then the question is like, what are we including? We are including this bintrap.h. Is this the only include here? Include is like import, right? It's the same as include in C or C++. We are including some more stuff here. Now, what's the difference between an include and an import? Like, this is like, let's assume a general question. The difference is that include is a super simple mechanism where it's usually, it might vary, but here I'm pretty sure that's the case. But takes the content of this file and explicitly pastes it here. Like, this line is being thrown away, and instead of this line, we get the whole file just copied in here before any kind of compilation. And we will have to do that in a second. An import, on the other hand, usually deals with modules. And a module is, let's say, like a totally different entity. And what the import does is just like loads this separate entity somewhere. So when something is needed from that module, then it's just being fetched from the already loaded module, which is somewhere else. It's like a higher level, higher abstraction level thing, basically. It's like we do not define where is it exactly, but it's not just being copy pasted in the same place. But here we have like same like C and C++, we just have an include, which is a low level mechanism. Okay, so we are basically, let's go, I'm going to go here. We need to take a look at this bintrap.h. If you are wondering why the file names are looking like capital letters and like short, because on DOS and other older systems that you typically had this like 8.3 file name style, meaning maximum 8 letters, then a dot, then 3 letters of extension, and everything was usually capital letters. But kinda changed later. Like now I think almost everything is only lowercase letters, but yeah, as you can see, like it was typical to just write in most of the stuff in capital letters. Good evening, Adam. Cool. So yes, this is this where we find our macro? Because there were two other includes which we'll have to handle as well. So let's go to that dermac. Yeah, dermac. Here we go, and let's look for, yeah, it's defined here. There's dermac macro x, and then this. Okay, what is this public? I have no idea what's going on here. Public there and x, and there and x. This is going to be painful. This is a string concatenation. A macro-based string concatenation. It's same like hash, probably. It's probably the same as hash in C, or like a double hash actually. So yeah, what this does is basically, in this place here, we will get there and whatever is the parameter, like let's say there are ASDF, like, or rather public there ASDF, and here we'll have there ASDF and a colon and like move whatever. So yeah, but this is a problem for future us. This is a problem when we'll be doing macro resolution. And now I'm wondering, because I'm wondering if this character isn't being used for like the end character, the ampersand. Ampersand is the correct name, right? Whether the ampersand is being used for a binary end in some context, and in other contexts, like here, it's just being used for string concatenation in the macro resolution. And if so, then I guess the question would be, the question would be, did we parse somewhere else this character as a binary end? I don't think we even got to the point where we care about that the ampersand is this operation or that operation, but I'm just curious. So let's do rgrep. Rgrep. Yeah, let's look for this. We need it in the single quotes, otherwise it will be interpreted as bash command, put something in the background. How was it like -a for ASCII? I think it was -a. And now okay. Yeah, here, this OEM H, but that might be, but let's take a look at the file. .h, this might be macros anyway, db space, yeah. No, it's macro still here. I don't get this one though. Well, maybe I'll get it when, oh, it's probably O for octal, okay. So actually this include and the macros work like a preprocessor. Here's the question, do I need to do something about it? Because a preprocessor usually runs before the compiler, and currently I'm doing already the compilation, right? The parsing of the compilation. Maybe I should do it in like 2 stages. I should do first I should do the preprocessor, and then I should do the compiler. That's one way to do it. The other way to do it is to no, I don't think we need to do it like that. I'm kinda a little bit afraid also. Okay, what's this? If not B, then and then and if. Yeah, this preprocessor is going to be a pain. I have no idea what NB means. Is it like non-zero? Is it 0? Let's see where it's used. Oh, if not B, maybe it means like if B is given. Let's grab for it. But that's kind of a problem of future us. Okay, so we have like, for example, here, this and the... Yeah, it's probably going to be if it exists, then just give it. Yeah, if like... I don't get it why it's like NB, not just if B. What does it stand for? If BD... Yeah, we'll have to resolve it. Okay. So... Okay, we do not have to change our code too much. But at the moment when we encounter either an include or we encounter a macro, well, not a macro definition, but a macro, then we have to immediately switch to resolving it and emitting proper tokens in that place. Can we do even like that? Yeah, let's try it like that. There might be a lot of edge cases, but I'm curious. Maybe it will just work, and it will save us some time. Okay, what we need to handle first, we need to handle include. Here is the include, and we are not handling include in any specific way. We are just like saying, hey, there's like, let's run it, and let's look for include, and we have an include here. Yeah, we just add an expression like this. And we cannot do this. This is incorrect. Or rather, it's not like fully incorrect, but we have to already here put the file actually here. like the fully parsed file, we have to put it here. Which means whenever we are encountering this, instead of generating the tokens and moving, okay, so we do this, but we do not append. Instead of appending, we need to start processing that file. And we need to get tokens which are going to, from that file, and be inserted here. I really hope that this is just a simple preprocessor and it doesn't do any magic. Okay, 221. How do I do that? Is the... Okay, the file name is just the file, that's good. So I do parse. What does parse return? This is the parse, this is the one we are doing. It should return tokens. It doesn't return anything, because I didn't do return tokens. Okay, here we go. So we are processing the tokens and we are returning the tokens. And that's fine. And now, having that, I'm going to do parse. There is one stupid thing I'm doing, but that's fine. We'll get to that. Or we will not get to that, because the stupid thing I'm doing is that if the same file is being included in multiple .asm files, then I will process it multiple times. I will not cache it. I can easily fix it, but maybe that will just take half a second more, and for fixing it, it will take me 10 minutes, so maybe it just doesn't matter. Okay, so we do parse and we grab the file. Parse the file, and then we get the tokens. The expressions. What we actually get here is the expressions. And what we do now is, to our expressions, we actually do append these expressions. Here we go. There is obviously a case where we are failing the expression parsing, and it's just going to be null. So if expressions is null, is not null. Sorry, I'm programming too much in JavaScript, do something. Well, maybe not too much, it's a fun language. Then, if it's known, then sys exit. Oh my. Okay. Oh my isn't the best error message. Are we using any kind of error messages, or are we throwing some errors? We are not doing that at the moment. Okay, cool. Let's run it. Okay. It says it cannot open the file. Why? Because the file is in a different directory. How do we fix that? Here. Are we importing OS? No, import OS. Okay. Dir name? Was it dir name? Python 3 import OS path dir name ABC. It should give me AB. It gives me AB. That's fine. Okay, so source CWD is the OS path dir name of the file. Okay, and now I need to pass it this directory name to the here. Process tokens, the source CWD. Cool, and now when I'm doing this include here, I should do ospath join and give this and this. Okay. Ospath join is, if you're wondering, it's a really long way to write this plus arc. Like, yeah. This is all it does, but it's going to use a backslash on Windows, and it's supposedly better to do it. There are some reasons to do it, but I don't think all of the reasons why you should do it are implemented actually there. What I'm going to write here is a debug message. It's parsing, or like including file, and then yeah. Here we go, and run it. Okay. And yeah, it started parsing and dead immediately. That's fine. It died at line, at this line here. So this is still the tokenizer. This is the, like, how do you say, first pass. Yeah, this is the first pass, and the process tokens is actually the second pass. Okay. So yeah, I'm kind of adding recursive parsing to it. And it died at line, I don't know which line, because there is the key error, because we are not, yeah, it immediately like went to this file. No, is not this file, is this file. And everything was fine. I'm sorry, what's this? Yeah, we are going to have fun with it. Okay, so it somehow still managed to pass through it, and then it, yeah, was killed here. Because in our token selector we do not have anything to do with, yeah, let's just add the like angle, left angle bracket, left angle bracket, right. I'm not going into mathematical names of it. Mathematical names being just less or greater. Not because I don't know it, it's just that we still don't know if it's going to be a mathematical operator at this. Yeah, so I'm just going to call it an angle left, angle right. To call it angle left or angle right, I do need to add this. Okay, here we go. So now it should survive it. What? Do I need to add it somewhere else? Did I save it? Why are you dying? I'm missing some. There was one more place where we had to add it, right? Yeah, because here I added it to the simple map, but I did not add it here to the simple map. Yeah, now it's better. Okay, and now we are getting an 1A. What is 1A even ASCII? Wiki ASCII. What will be the use after building it? That's a great question. There will be little use. We'll just compile it basically and run it and play a little bit with it, and that will be it. Just an exercise basically in building an assembler, I would say. That's Polish, right? Which means it's probably encrypted for most of you, so let's just switch. Okay, I'm looking here, 1A. It's a substitute, or is actually like this is a line termination, or not a line termination, a data terminator, like end of data. 6 stop is what it's called. Okay, cool. So where are we finding it? Let's do cat GW, no, it's bin trap, and let's do hex dump -c. I expect it to be at the end of the file, and it is at the end of the file. What do we do with it? We absolutely ignore it. I don't care. It's basically just marks that it was at the end of the file. It's not something used, but On Windows, if you would use it on Windows, it would actually work. As in, if you'd open the file not in binary format, but in text format, and read through it, after the reader, like the part of a system or the library actually, what's doing the reading is going to encounter this byte, is not going to read anything that might be after it, because, yeah, it's just a stop for it. For Windows, for the text mode. So, yeah, we do not care about it. How do we just get rid of it? I want to just get rid of it. Let me think what's the easiest way to get rid of it. Here we are doing some parsing, blah blah blah. Okay, it splits the lines. And then it replaces 0 with this, and we want to do the same with like x1a. No, that's fine. Okay, it works-ish. Yeah, I also hope that you kinda, like some of you already know it, but some folks might start to look at code differently, right? Like look at the code like at this line, not as a magical line, but like a series of tokens and expressions, because that's how the compiler sees it. And if you know that, you're going to have less problems with syntax in understanding syntax in programming. Okay, we need less. That's a lot of code. Okay, so we are including the bin trap, we are including OEM, and okay, I like it. What it doesn't do right now is I want it to fail. I want it to fail hard when it encounters something that it does not understand. How are we going to fail? We are failing here. We are going to do a return none. This will fail. Yeah, this is perfect. Okay, so we parsed completely this file, parsed in the first stage. It was not parsed correctly in the second stage, and we will have to parse it in the second stage too. But before we get there, no, maybe we should actually focus on that. Focus on making sure this bin trap is actually being correctly parsed. So how do we do that? I wanted to output all the tokens, and to output all the tokens, I need to do here in the include. Okay, we are including the file, we are parsing the file, we are getting this, and now I wanted to print the expressions. And it doesn't. Did I save? I did save. Because, okay, sorry, because this file probably includes this file. It doesn't, we didn't return from it yet. Let's go to here, include, yeah, well, obviously, there's this include. So, okay, never mind. This is working kind of like intended, and we do need to focus on the OEM. And we are having an ident there. Let's go to OEM then. Okay, hello, what's going on here? This is fine, we are parsing this correctly. This is fine, and then we get to macro. Okay, the issue is that we do not understand macro yet. We do not know what macro is. So yeah, this is the moment which will allow us to really move forward if we implement this. Let me check if I do have macro somewhere here. No, it will be in a different place. If it's an ident and a label, but it's not. If it's an ident and an equal sign, but it's not. If it's a macro is also an ident, like identifier, right? Because we don't know it's a keyword at that point yet. We kind of could make a list of keywords actually, but whatever, doesn't matter, doesn't matter. So label here, if, and next one is, where does it say label? Is there something like that, like label? I don't get this one. So type label, oh no. It's +1, right? The same one, oh sorry. If the token identifier is a label, let's read it. It's a variable label. Now, let me just quickly air grab label. -a. Okay, here we have this label word. That's weird. Oh, it was when importing. That's weird that they're using, you know, like here label as like some kind of a name, and here they're using it as like not like a name. Okay, we have to keep it. It's kind of weird, but we have to keep it. So let's keep it, and let's go back here to this problem. If we have an identifier here, why is it +1? You don't know my... Okay, if it's public, then something. If it's a label. What I needed is, I need an identifier, and so this one is an identifier, and the next one is also an identifier, but it says macro. This is what I need. And then I'm going to go, let's look at a macro. Let's learn how to type a macro. No macros here, okay, macro. Macros have parameters, right? Yeah, and they're like comma separated. Well, these ones don't. These ones do. Yeah, like here. We have the name, we have this keyword macro, and then we have a comma separated list of variables. I think we are already parsing somewhere comma separated list. So let's get all the tokens until the end of the line. This is correct. We are grabbing that. And we are grabbing them from not I +1, but I +2. Then we have the macro name, which is args 0 of 1. This is 0, yeah. This is it. This is type is identifier, and this is the name, so that's the name. And then we have the parameters, and before we even add anything, we do not add anything. This will be kind of weird what we'll be doing here. Let's do a sysexit here for now. Macro stuff. And let's just print args. Okay. Here we go. And it says index out of range. Why are because this should be I, obviously. I index out of range. It's tokens. Okay, that's better. Yeah, it doesn't have any arguments. Some other macro might have some arguments, and now what we need to do is we basically don't do anything more. Yeah, that's kind of weird, but we don't do anything more. We start grabbing all the tokens like level 1 tokens, and copying them as they are. Grabbing, and then when we reach end M, we stop. And we say this is the end of our macro. So a macro will be a name, a list of arguments, which we do need to parse. We are not parsing them yet, we will parse them in a second, and a list of tokens, of level 1 simple tokens. And then when we encounter something which is an unknown identifier and it's actually a macro, we need to register this macro somewhere. I will do it in a second. Then we basically do what include does, but with resolving some of the stuff. But that will be done on the moment when the macro is used, not here, not now. Which is lucky for us. Kinda lucky. It will be a little bit annoying because of the fact that macros work a little bit differently. There will have to be another function. When the macro is being called with arguments, there will be a function which is like pre-process the tokens for a macro, and it will do everything and then return a list of simple tokens which will be included in the simple token list, and then it will be parsed. So it will be kinda like include, but we will be, instead of just including stuff, we will be actually, instead of getting parsing a file and getting expressions, which are a level 2 thing, a second pass thing, we will be getting first pass things, which, yeah, it's kind of weird. You'll see. Cool. What we need to do now is we need to parse the arguments. Do we have any comma-separated parsers? I'm pretty sure we had some comma-separated stuff for... Do we need it for EQ? No, we need it for like dB or something. Where's the comma? No, we don't have... we don't have support for comma-separated arguments anywhere yet? Okay. It's kind of weird. I kind of remember writing it. Oh well. We have label here. Wait, did I do it in the correct place? I didn't do it in the correct place because the label was supposed to be here. That doesn't matter, it's fine. These are like equivalent. Okay. So this is not needed, but I'm going to leave it here. Yeah. Let's start with argument. We are printing arguments, the arguments are not there. Can we parse a different file to get the arguments there? Let's actually parse a file which is called this one. This one has this include, so that will... Let's comment out the include for a second. Okay, I'm going to open this file, and I'm commenting out the include here. Now I'm going to run parse, and it, yeah, exactly. And it goes here to this macro, and this macro has parameters. So there's like parameter, comma, parameter, comma, parameter, comma. And what we need to do is we basically go through how to do it. Params. Let's do like this. Now we do for... I'm sorry. Close your eyes. J name in enumerate. Did you close your eyes? I hope you did. If J2 is 0, then we are at 0th position or 2nd position, then we just params append param name. Else we verify that tokens of I of 0 is a comma, is an identifier comma operator. Do we assert it? Let's just do it. How to check. Okay, yeah, this is ugly. I'm sorry about that. Does it work? Yeah, it worked. But I append here with param's name, param. Param's name is actually this one. And we do need a, well, we don't need, but let's do a check here. A check if it's an identifier. Okay, that's unexpected. Oh, J, it's J, obviously J. Okay, and here J, yeah. What? S tokens, not S tokens args. Actually, no. Let's just do param here. That's the same thing. Well, yeah, that's the same thing. I'm getting confused. Not 0. Well, no, 0. Actually, 0. Okay, that's good. Param of 0 is not an identifier. We are he. Wait, let's do this. Oh, that's not equal, not equal. Yeah, we are only exiting if it's not equal. Okay, no. Yeah, cool, now it works. Yeah, so basically the idea is that on every even position, like 0, 2, or 4, or 6, you have an identifier. And on every other position you have a comma. So this works even if you have only one parameter with no commas after it, because it will still expect here an identifier. Yeah, here we have an identifier, and it will be expected. And this will not like, nothing else will be checked, because yeah, this enumerate will run out of arguments. So yeah, now we have a list of parameters, or actually of parameter names, which is fine, and that's a list, so that's fine. Okay, cool. So we have this, we do not care about this, we do care about, let's call this macro params, maybe macro. My error reporting here is like terrible, is like worse than GCC 2.0 had, and it had terrible error reporting. Macro. Name, macro params. And now what we need to do, macro name db. That's what? No. How did it get db? That's wrong. Oh my. Yeah, because we are overwriting I. Do not change the files too much. Movri. Okay, and now what we need to do is we need to grab all the tokens until we encounter this token and m. Okay, does it work? Yeah, it works. I guess there was a... Yeah, I explained it to you until I understand. That's true. That's true. That's like, it's called rubber duck debugging. Like, look it up really on like Wikipedia or whatever. There is something called rubber duck debugging, and that means when a programmer is trying to explain the code they have written to a rubber duck, or like a teddy bear, or whatever else, like another person, for example. And during the explanation process, you sometimes have like an aha moment where you say, yeah, this is what the code is supposed to do, but it actually is doing something different, because you're explaining what you think the code is doing, and you're looking at the code and you're like realizing, yeah, this is like not what it was supposed to really do. So yeah, this is exactly what I'm doing as well. This live stream is kind of like a rubber duck session. You are all my rubber ducks, or whatever you prefer to be. Thank you for being here, basically. Cool. Now we need to grab all the tokens until the end L. Tokens like macro tokens. It's actually going to be an array, a list, if you will. Oh, what happened to my Discord? Okay, here we go, cool. I'm going to do a break in a few minutes, as soon as I basically get these macro tokens, and I'm going to answer some questions, and then we are going to implement some more stuff. Where is my water? My tea ran out. This is terrible. Okay, so while true, while, is this what I want to do? No, I want to do a while true. Infinite loops are amazing. If s tokens of I, okay, let's do like I plus no. Okay. If s tokens of I of 0 are and L, what is and L actually being parsed as these days? And L, this is probably going to, sorry, and M, and macro. This is, yeah, probably and ident. So let's go back here. If this is an ident, identifier, and it happens that this identifier's value is actually and macro, so it's on the first field, then we break. But before we break, we increment I one last time. Okay. Otherwise, we increment I one more time. Do we do this? Do we do... Yeah, we can do this here. Okay, yeah, and here we increment it again. Otherwise, we just copy the tokens. So macro tokens, append. We could do it in a different way. We can just find and macro, get the index of it, and copy it. But yeah, let's just keep it simple. It's slightly slower, but we don't care. I think it's slightly slower. Okay, append this token. This is fine, this is fine. Okay. And here we can, let's go here and we can print the tokens. So we know that we get all the tokens. Okay. Boom. Here we go. What do we have? We have arguments. We have the name, sorry, the parameters or whatever. Well, arguments, actually the arguments, right? And then we have the tokens. We have DB token, literal token, and let's look here. D is the last identifier. D is here, and D is here. And then there's an endline token here, and then there is end M should not be on the list, and it is not on the list. So that's perfect. Now we have a macro. And we need to register this macro. We do not add it to the list of expressions. We do not do this. We do not care about this. What we do is we register the macro. To register the macro, we need to have some kind of macro, and this is going to be painful again. Let's do this, macros. And a common mistake which people would make is that I want macros to be a dictionary, and I want this dictionary to be passed recursively, so that every recursive call actually fills the macros. So what I need to do is I basically need to do in the process tokens, when I call it, here I need to pass it an empty dictionary. Why do I need to do that? Another way to do it is to here just do a default value of an empty dictionary, and now when I'm going to use it, and I'm using it in parse, I have to pass it here in parse, but I'll get here in a sec. Why not do this? Because Python is kind of funny. As in, this actually would create one global, super global dictionary, and it would be used by every process token function ever. Not only recursive ones. Why? Because this expression actually for Python is a little bit different than for us. We see it as a separate entity, as a function definition. And for Python, this is actually a code which is generating a code which is doing basically something like this. Process, let's start maybe here. Process tokens is equal to make function, make fun, and then arguments. And one of these arguments is basically a table of parameters of arguments, including the default values. There will be another one which is basically of default values. And already at this moment, this has to be resolved. The value of it needs to be known. The value or the actual object there. So this would actually mean, hey, create one super global dictionary and put a reference in the default values to it, to this super global dictionary. So this super global dictionary would be always used when process tokens is called without a default value. This one, not a new one. What we would expect, kinda like from other languages, from C++, for example, is that a new one would be created for each function call without a default value. I think in JavaScript it would be actually the same as I mentioned, but in Python it works like this. At the moment of the registration of a function or making of a function, this dictionary is going to be created and is going to be used. So yeah, there you have it, some Python weirdness, if you like. It's sometimes, yeah, this is a mistake you make at some point in Python, and then you are hunting for the bug, what is wrong, for an hour, and then you read about it and you're like, oh, so it doesn't work like in C++. Yeah, it doesn't. Cool, so macros. So this is macros, and what we are doing here for the macro, we are actually registering it. So the problematic part is if macro name is in macros, then we kind of have a problem. Macro already defined, and we give it the name. I guess I should write it in a new Python version. Why am I even using this old syntax? The new syntax is pretty cool. Okay, so now we know it's not there, so we do, this is single threaded, so that's fine. yeah, my mind is always like, is this single threaded? Do I need a lock? There is a race condition here between the time of check and time of use. Is it fine? Yeah, it's fine. This is single threaded, but something I also thought about. And we put the macro and we register the macro. So let's just do like, yeah, since I have it already, I'm just going to copy this and do this and do this and do okay. This is kind of weird, but fine. Okay, tokens, not tokens, but yeah, that's token. Okay, that's fine. Yeah. Okay, and then we continue. We have I set to after the end macro token. We made sure about this here. We are adding the macro call. Now we need to make sure that macro is being passed around correctly. So that means include when we do parse. This needs to have the macros as well. So we do macros. Yeah, and this is where we need to do it. Actually, there's a better way to do it than this. We call parse, but here we don't call parse. We do a different function which is called worker parse. Or parse worker, whatever parse worker. And this, yeah, what we do is we do return parse worker fname and a new dictionary. And this is the way we are making sure that this is going to be not a like super global. It's not a super global, it's actually a module global, but that's fine. So yeah, this is going to be fine. Now, when we are calling parse, here is fine. Here we are calling parse worker, and here we are passing the macros. So that's one thing. Now we go to parse again, and parse is doing this. So we need to put the macros here as well. Yeah. So the simple tokenizer is going to be called. Yeah, simple tokens are called here tokenized. Tokenized does not require this thing, only parse requires it, and process tokens requires it. I think we are passing it correctly. Let's see if we are passing it correctly. Let's do this. And it says, oh my, because I don't know, but let's uncomment this include. Okay, macro already defined. Yo, you are kidding me. Where did you even define that? Compare. Okay, what's going on here? Why? Okay, why? How? These are my two questions, why and how. Why do they have a macro of the same name, and how did it compile? I don't know. This looks like like an actual bug in the code. Yeah, okay, let's do questions now, and I will think about what to do now, because you cannot have two macros of the same name. That is not how it works. Okay, the questions will be shown here. Again, if you have a questions, just do !Q and then the question, or ask our moderator today, Foxtrot Charlie. You see his nickname right here. Thank you, Foxtrot, for being here. Now, now we are doing a 10-second break because I need to grab more water, sorry. Okay, folks, I do have water. I can answer questions. Okay, Jiri writes, or is it Yiri? Yeah, sorry, I'm not great with names. My apologies. What's your opinion about Intel's set? Do you think it will have any meaningful effect on security? It's bypassable, but it's a good move. It's a good move, but it's a mitigation. Mitigations are usually bypassable due to the complexity of code, but I think it's good that it's being added there. I see there are only 2 hard things in your shirt I want to do. Okay, yeah, so again, you probably already saw it now, but, well, yeah, here we go. You can find it on, like, the internet. This is a common joke, a common programming joke. Usually it goes without the asynchronous callbacks. It's just like, there are only 2 hard things. That's naming, that's cache invalidation, and that's off by 1 errors. But there are even, like, jokes. This joke can be extended easily. GCM writes, memory corruptions are increasingly difficult. That is true. What are some promising areas for future of hacking on the offensive side? Like, I mean, web security, I guess, is the obvious answer. There's a large surface of attack, and web security is just super complicated. And it's not as complicated as low-level security, but it's close. Actually, it's pretty close. So, yeah, I mean, that's a huge attack surface. That's a larger attack surface than low-level security and memory corruption. So, absolutely web security. And yeah, there are some even more complicated stuff. It's kind of funny when you think about WebAssembly, right? Because WebAssembly, you can compile a C code or C++ code to WebAssembly, and then you have like buffer overflows and other stuff. There was some cool stuff published about it, like about, I think somebody done a survey of memory corruptions in C++ programs compiled to WebAssembly. There's a paper about it, but yeah, just look it up. Like, Google it, because I honestly do not remember the details. And yeah, and web security is easier to start with too, because a lot of websites, a lot of companies just do not do security. It's not that they don't care about security, because that's not absolutely not true. They do care about security, they just do not know how to go about it. And there was also some research done here, right? There was a case a year ago when some researchers basically hired, I think, like 20 different freelancers or companies that are making websites, and they asked them to do a website, and then tested the security of the websites, and it wasn't good. Basically, like, most of them did contain vulnerabilities. Not all of them, I think, but most of them. And then they asked, I think, to correct some mistakes, and still, like, the corrections, the fixes weren't great. So security is hard, and the problem is that framework creators, language creators don't make it easy for folks to create secure products. It just, no. And they should. Ridanius says, can theoretically everything be sandboxed? If yes, why practically is less possible? I do not count resource constraint embedded, of course. It's like this. Yeah, so resource constraint is one thing, right? Like, it slows down. Not a lot. If you do it correctly, it's not a huge slowdown, but it's like this. If you have a huge system, like, think of a web browser, and or like, I don't know, like Apache server, and you suddenly want to sandbox things. Well, the principle of, like, compartmentalization of basically least privilege and so on says that you should separate it into parts which have requirements of the same time. Like, for example, if you have a part which really requires access to this piece of user information, and another part which requires access to a different part of user information, then these parts should be separate, and each of them should have the privilege only to access what they need to access. And then you can grab these parts and put them in separate sandbox. And suddenly you find yourself that, hey, I need to do, like, I don't know, 30 different sandboxes. But that's okay, that's doable, but now you need to communicate. And modern sandbox libraries try to give you some ways to communicate with what is inside the sandbox. And that's usually a different process, right? So you need to be using, like, pipes and some other stuff. I think, yeah, there is basically you need to use, like, inter-process communication for that, with some serialization in the middle. So that's code to write, and to take a product and then sandbox it into with 30 different sandboxes takes a lot of time and a lot of resources from the programmers, and it will slow it down too, because suddenly instead of just passing a pointer to a memory structure, you have to do inter-process communication to send the data and get the data back. So there's that. So it's better when you create a new product to make sure that you have a lot of compartments and each compartment has only some privileges, and design it from there, go from there, which will make the implementation a little bit painful, but it's less painful than trying to grab a part and rip it off of the rest of the system, which is usually really entangled too, and put it in a separate process, in a separate sandbox. So you can sandbox a lot of things. You cannot sandbox everything. It's really hard. It's super hard to sandbox stuff in the kernel. It's easier to sandbox stuff in the user mode. And it's easier, the higher level language, the easier is to sandbox stuff, basically. So yeah, there are problems there, which needs to be solved. Also, if you grab an untrusted library, you need to write a sandbox about it. And a sandbox is as good as the policy of the sandbox is. So if the policy is yeah, allow everything, and you then say, yeah, we have it in a sandbox, but well, the sandbox just allows everything. So, well, that's not really a sandbox, right? So you have to make sure that it has enough privileges to operate, but not more. Again, the principle of least privileges. And so that's work. And I don't know, when the library changes and it suddenly needs another privilege, so you need to be aware of that, and you'll need to update it in your code, and you need to basically make sure that there is no programmer in the future that comes and say, oh, we have these problems because the sandbox is restrictive, let's just allow everything. Because that's an easy thing. Now we do not need to put money there to patch it all the time and figure out the new policies. It's just going to work. So yeah, there are some problems, non-technical problems with sandboxing as well, but a lot of stuff can be sandboxed. Then we encounter the problem of what is coming out of a sandbox should not be trusted, as in, which means, on the other hand, that what is coming out of the sandbox should be as simple as possible. For example, you know Cubes OS. If you don't, it's basically, well, you need to check it out if you don't. Cubes OS, here we go. It's basically Linux distribution which runs applications, each application in a separate virtual machine. That's a gist of it, basically. And it has a set of built-in connections between the virtual machines. So for example, you can copy a file from one virtual machine to another, from one application to another, because again, that's separate applications. So that's a great thing, because if somebody hacks your web browser, which you are using for looking at funny kittens, then they don't get access to your web browser, which is a different instance, different VM, which you are using for banking, which is great. Now, the problems are, well, sorry, not the problems. I wanted to say about the design. They made a great choice about the frame buffers, because you see the applications just as normal windows. Is there some kind of show me screenshots? Here we go. Oh, that was first link, right? Yeah, you have it like this. But this is, the color basically tells you what kind of which virtual machine it is, and you see it each application has a normal window. It's not you do not see the full desktop of a virtual machine. You just see the window of it, which means that each virtual machine basically has a fake software graphic card, an emulated graphic card, which sends the frame buffer. And there could have been a lot of bugs there, but they made the protocol for sending the frame buffer super simple. And yeah, it's piece of the code which is piece of the data which is untrusted, could contain data from an attacker, but they made it so simple. It's basically super easy to audit, and it's unhackable. So you have to, when designing a sandbox, you have to take into account that you cannot have complicated stuff coming out of a sandbox, because it will be an attack surface. By the way, in Cubes, at one point you could even run Windows applications on it. Oh, like here, for example. these are like, you know, Windows stuff running on the Linux, because they also could create VMs of Windows. The amount of work and the amount, like the technical stuff that went into having Windows applications there was just amazing. I know people who did it like for a long time basically, and they are absolutely amazing. They really know what they're doing. So yeah, Cubes is pretty cool. But yeah, if you want like to sandbox everything, you will have some other problems. So in case of Cubes, for example, you do not have access to a GPU, a full access to a GPU from a virtual machine for obvious security related reasons. Good question, good question. Lazy Turtle writes, how's the weather in Swiss? Do you have mosquitoes there? Thankfully, there aren't too many mosquitoes. There are, you can find like every month you will find a mosquito basically. Unless you, I guess, are in the woods, then every month you will find 2 mosquitoes. Which is totally different than in Poland when, you know, I'm from Poland, right? So, yeah, I remember that like there were like just swarms of mosquitoes sometimes in like city center, for example, which wasn't the greatest, only in summer. But yeah, when I was really happy when autumn came basically and mosquitoes went to sleep or whatever they do, went back to hell. So yeah. Thankfully there are not a lot of mosquitoes. The weather is pretty nice. It's not too hot, it's not too cold. It's like a summer weather, but it's a decent summer weather. I'm not sure where you're from. If you're from like European countries, it's like pretty similar to what's in Germany, Poland, or France, I would say, like the northern France. Cost Karubika Rise, what do you think about the Dart and Flutter framework? I wasn't convinced by Dart, but that's my personal opinion, and in honesty, I looked at Dart like 9 years ago last time, maybe 8 years ago, I don't remember. That was a long time. I might look at it again for some reasons in the future. I do not know Flutter. I need to check out Flutter. It is on my to-do list. So no opinions, basically, just like, yeah. Dart, basically, if you don't know, folks, Dart was a language which is kind of like JavaScript, but it was supposed to, or actually did fix some issues which JavaScript had. And it could be either integrated with a browser, or it could be compiled to JavaScript. So it's kind of similar to TypeScript if you think about language types. Yeah, but that was, again, I looked at it ages ago. A lot probably has changed. Okay, there are no more questions. And if you have any questions, again, write !Q and then the question, or you have to ping our moderator, Foxtrot Charlie. Okay, so now we can actually go back to doing macros, and I'm a little bit we have to resolve this compare issue first. What do we do? Let's issue a warning, and let's say that, yeah, it's not great, but I'm going to allow it, and the new macro is going to override the old macro. I do hope they do not have Svina. If they have Svina, like, you know, like Svina, this is a term from C++. It means like substitution failure is not an error, which means that if you have like 10 declarations of templates of the same name, and you are resolving them, then if a template resolution fails because the types don't match or something, or like something internally just doesn't make sense, then that's a substitution failure. And it says it's not an error, but this will not be an error that the compiler will display and stop compiling. It will just say, okay, I cannot use this template. I will use the next one in line. So I really hope that in their case, it's not something like this. It's not that they have like 2 macro definitions and only like one will work, or like maybe all will work, but you grab the first one, and if the first one fails due to syntax error or something, then you take the second one and use it then. And I really hope that's not the case. Let's just print an error here. So print macro already defined, and this is going to override the macro. Let's do. As like this. Okay. Yeah, it seems there are like several macros which are like that. Let's look at the second one in that case. Anyone seen my browser? Here we go. Yeah. Oh, but this one is the same, thankfully. That's good. That's something. Pop R. Pop R. Okay, which one is first? This is going to be a problem. Because as you can... No, it's not going to be a problem because we are overwriting it. As you can see, they kind of expected to have B and D here as parameters, but they don't have it. But since we are overwriting it, then we get this, which is fine. We just pop into CX and DX, that's fine. This, we can compile this. Now let's go again to this compare thing here. And this is a call decompare, and then this is 73332. I kinda want to know what's that. So what do? We do Python, we do 0, that's for octal 73, and we convert it to hex because I need to see what's the hex value of it, and 332. DA, 3B DA, and let's go to... Where do we go? We go to Gunvale Vexillium.org and to this wonderful complete Intel, complete Pentium instruction set table by KrzaQ. It's 32-bit, but I don't care because the opcodes are almost identical, and I'm going to look for opcode 3B. 3B. Too far. 3B. That's a compare. Okay, that's a weird one. No, wait. It's supposed to be compare, right? It's supposed to be compare. So that's fine. No, that's okay. That's fine. So yeah, we either get call compare or we get this. Okay, I'm fine with it. This is okay. It's weird, but it's okay. Cool. So now here's a funny question. Why does it complain about and L? It says it gets a page, and we are parsing OEM, including file and print expressions. So we didn't get here. Okay, that's good, because then the expressions will be actually printed. If we didn't get there, then there might have been no expressions, but then, okay, then we would have been printed just an empty array, that's fine. Okay, at the end of it, this is the page and this is .m. And this is .m here. What is going on here? We have a DC macro which has an arc, and then we have IRPC, ZZ something, and macro page. Why? What's going on here? What's... Oh, okay, this is probably if this, then something. What is IRPC? I do not believe this is going to be an RPC call. Grep IRPC. No. This is weird. I do not know what IRPC is in this context. Assembler. This is one of the first things we have to... Oh, okay. That's nice. C fork. C. Okay. Marks a block. Okay, so okay, that's fine, that's good. That will be repeated once for each character of a string. Oh, okay. So it's going to be a for each. ZZ from the string argument. It... Wow, okay. That's a string parsing. That's weird. Yeah, and this we already said, this is string concatenation. Okay, oh, I get it. So DC is basically emit a string, because they cannot emit a string. And it's a string like you start with quote, then there's the string and we end with a quote. And this is going to emit the full string. Why are they doing this? I have no idea. Where do they get A from? This is going to be a little bit funny, but that's fine. Okay, no, that's fine. Sorry. What I am mad about is that they are using &m again. So that means that we are hitting this. When we are going with macro, they are hitting this again. They don't like us. Which means we have to go to macro here. Okay. This is fine-ish. If it's an identifier, and that identifier happens to be this IRPC, then we have, let's say, like IRPC push count, push count. Okay, push count. As 0, then we increase this push count. And then we go through everything else, that's fine. Yeah. Now here, if we get &m, if another requirement is that the push count, no, here, if the push count is 0, then we just do this. Else, if it's non-zero, we do, yeah, we continue. We just do push count -1, but we do add it to the tokens. And thanks to this, we will, for each IRPC, we will, that's probably like I repeat character. I don't know what I is for. Iterate, repeat character, no, that doesn't make sense. Yeah, so basically for each IRPC, and there might be more stuff here that we'll add later. For each IRPC, we'll need one more &m, and all the previous &m's are going to go here, which is fine. Let's just parse it. Okay. Why does it? Oh, okay. Yeah, it's not happy about page because it never actually reached page. Page is always at the end, right? Let's look at a different file. No, page is not here. Where's page? Page. What does page do? Okay, can this modern Visual Studio thingy tell me what's page? The first says the line length and character width of a program, if no arguments are given, generates a page break. Okay, this is if we want to print it. We don't care about printing. I'm just going to ignore it. I'm going to treat it like a no operation. So if it's, let's just go here. It's an identifier and it's page, then just grab the arguments. Don't add any expressions, we don't care, and we continue. Perfect, here we go. No, here we don't go. Why don't we go? Because we need this. Now, here we go. What happened there? Okay, we are still parsing this because we didn't output anything else. Okay, there are some more questions. There are more questions. I will get to the questions in a second. Yeah, I think we'll have to do macro resolution on the next live stream. Next live stream is probably going to be about Hack the Box, probably. So yeah, so this will be a little bit delayed by 1 or 2 streams. That's fine. We're in no hurry. I think we are not in no hurry. Okay, if while list art out of range. Okay. Here. No, where is it? Because I know it's in. Oh, right, because I said I'm going to treat it as a no-op, but I did not treat it like a no-op. That's my bad. I'm still doing this, so shouldn't do this. I should do this. Yes, it works. Perfect. Macro move RE already defined overwriting. Wow. Okay, I am not printing this include. Okay, that's a little bit better. Now what I want to print, however, is after macro, no, after macro, after, yeah, let's say after include. I want to print macro. Macros and sys exit. Yeah, just do like this. Okay, so these are the macros. Now I want to print the macros in a nice way. Did I create a pretty print file? No pretty prints? Am I using JSON for that? Yeah, I'm just using JSON for that. Okay, we are going to do that for macros too. Include. Sorry. Here, macros, expression, macros. Okay. So these are not... Are these the macros? Yeah, these are the macros. So we have, for example, macro syncheck, and it has one parameter which is x, and then it has the tokens call, syn something, then line end, identifier db, offset x, and null. Okay. Then we have a macro pop r, and we do pop cx, then we do pop dx. Okay. And then we have this super long macro ldir. Okay, it's fine. It looks fine. I like it. Let's just remove this and let's see what's next. Now we are getting hit with if1. If1 is probably a macro. And that's probably a macro which is in here. If1, yeah, that's a macro. I don't know why. Oh, okay. It's doing weird coloring because it thinks it's C actually. No, that's an assembly. Okay, here we go. Yeah, it has this if and if. Is if and macro. Is it a macro? I don't know if it's a macro. I'll grab if1. It's not a macro. Well, why doesn't... why are they using small letters now suddenly? Did I press something? No. Okay. So this if1 and end if is something we'll have to deal with. I absolutely do not understand what is this supposed to do. Let's see if Masm, the new Masm, can also find me an if1. Nope. Oh, if1 and if2. Okay. Block is evaluated on first assembly pass on every assembly pass. Okay. I don't know. We'll have to figure it out. But okay, let's do questions and let's finish it here for the day. We are kinda... next time we'll have to do macro resolution for the second pass, and we should be approaching the end of the second pass, and we'll have to also do this like if not defined, if one, and whatever macro resolutions, so that's fine. And then we should have the second pass ready. And when having the second pass ready, we can go through the second pass and grab all the variables, and separate all the instructions and do other stuff, which should be super close to actually assembling the instructions. I will be using an external assembler. I will not be writing my own, so yeah, there's that. Okay. Yeah, what's Hack the Box? Hacks the Box is basically a set of, let's say, a pen testing exercise. It's like CTS, but it's more for pen testers than vulnerability researchers. Yeah, that's basically it. So I'll be pretending I know what pen testing is about, even though I don't. Cool, let's go with questions. There are a couple of questions. GCM writes, Are there still any promising areas of offensive research that involves low-level reverse engineering, in your opinion? Sure. But you have to go lower, I think, than memory corruption. There's a lot of stuff going on in... Well, that's not true. There's a lot of stuff going on the CPU level right now, as you know, like, you know, Spectrum Meltdown and all the hell that broke loose from that. Then all the non-x86, non-ARM platforms are... There are a lot of memory corruptions there still. If you want to exploit a buffer overflow, just like, yeah, buy a home router and play with it. It will probably be, maybe it will be even on ARM, but yeah, like, that's a good entry level to security, to low-level security, I would say. Is there anything else? I'm not sure. I try to think about it, but these are like the first two things which come to my mind. AMD versus Intel software developer manual. I do prefer Intel. I do like AMD too. It's different. Like, they are writing in a... These are like different styles, basically. AMD commonly has more information about undefined behavior, which, like, Intel says like something is undefined, and AMD says no, actually this is what happens. Yeah, you learn to use both. Yeah, especially if you're researching on the CPU level, learn to use both. The CPUs themselves in user land do not differ almost at all, apart from, you know, like 3D now instructions and SSE instructions. In kernel land, there are more differences. What do you mean saying VM on kubes? Just Docker, wine container, or really VM? No, that's really a VM. That's a hypervisor, based on a hypervisor on Zen, I believe. Yeah. So they are running Zen in the background, and they are actually having virtual machines in the background. That's not a container. Like, when Cubes was basically developed, and that was what, like, I think Joanna started the project around 2008-ish. Then there were no containers yet. Usagi Yojimbo writes, what do you think about interfaces, rather its emulator, or other advanced op abilities in Python? Op, you mean like object programming, I assume? Well, yeah, like there are no real interfaces in Python. Python has like a typical high-level language approach to classes, I would say, but it's more about like, if the names of the methods matches, then that's enough. And yeah, there is no strict definition of a class, what fields, what methods does it have to have. In honesty, I never used any advanced stuff in Python. I don't even know if there's any advanced stuff in Python to begin with. I didn't ever look for it because, I mean, I never needed it. Python class interface. Let's see if there's something. Maybe there were some yeah, abstract method and other stuff. Yeah, I never played with it. So I believe I'm not qualified to answer the question, basically. But that kind of seems like like a hack, like an emulation, like you say. But it sounds like an interesting topic to learn how it works. So great question, Usagi. I just have no idea. Aridanus writes, what's your opinion about symbolic execution? Have you used it for research? I always confuse symbolic execution and concolic execution. I think concolic execution was the one which is using input from dynamic testing, and symbolic was not using input from dynamic. Okay. Yeah, I always confuse them. So Z3 is basically for doing symbolic execution too, right? If I'm not mistaken. Z3 for symbolic execution. Yeah, okay, cool. Okay, perfect. Yeah, okay. Yeah, just wanted to make sure I don't mix up the terms, because I love to mix up the terms around here. I did play with it. It is useful. It's just not... It's not a silver bullet, but there are areas where it's useful. It's used in a couple of fuzzers where, well, like, I don't think any of these fuzzers are actually public, as in available to just download, but there are fuzzers that a couple of companies like Microsoft, or I think Cisco has, that they basically try to use symbolic execution to increase code coverage. Because what symbolic execution does for you is that you can tell it, hey, I want to reach this piece of code. What input do I have to reach this piece of code? Which is a really complicated question if you start to think about it. And it is able to do that, partially. There are problems with loops, there are problems with crypto, but apart from that, that's pretty cool. So yeah, it's a good research topic, I would say, and it's again common to use both symbolic execution and fuzzing at the same time to one basically. Fuzzers are stupid. Their power is that they are super fast, but even genetic fuzzers are pretty dumb at the end of the day. And symbolic execution is pretty smart, but it's both slow and it cannot solve all types of inputs, only specific types of inputs. So yeah, I like it. I used it for some stuff. It's cool in cases like, for example, where you have a piece of code and you have an encryption routine, but you want to generate a decryption routine. You can do it almost automatically in some cases with symbolic execution. Not really actually getting a decryption routine, but getting, basically if you have an encryption, right? Let's just use this as a notepad. In encryption, you basically have a ciphertext, which is an encrypted message, right? So encrypt M is a ciphertext. And assuming you have a ciphertext and you have an encryption algorithm, you want to decrypt M, but you need a decryption algorithm, which you do not have. So you can either reverse it manually, or you can make an equation. An equation would be, for this ciphertext, what kind of, this is an unknown, what kind of input has to be for this algorithm to get this exact encrypted message. And this is your unknown, your X, and a symbolic execution can get you an X. It might take an hour, but it might get it to you still. And yeah, this is like we used it on the CDFs. It can also do some other pretty cool stuff. So yeah, it's pretty cool. Like, learn it, absolutely learn it. It's a good tool to know. It's not a silver bullet, but absolutely learn it. And Z3 is pretty cool, especially with Python interface. This is really cool. There were some live streams where I used it. How do you fuzz device drivers, assuming you have no source code? Okay, I am almost always assuming I don't have a source code, so I would go the other way. How would you fuzz a device driver and you, for some reason, actually have a source code, which is weird. This is the weird thing to add. Anyway, never mind. Ignore me. Well, a device driver is basically what a set of... okay, depending from which side do you want to fuzz the device driver, right? Because you have two sides to a device driver. You have, like, this is your device driver. It lies in the kernel mode. This is the kernel mode boundary. This is where userland processes are happily doing something. And it has some kind of interfaces where you can interact with it. These are like devices, and this is the driver. And that's both on Linux and Windows. This is the same. And then it actually sometimes, but not always, it might chat with a device, an actual hardware, a piece of hardware, right? Think, I don't know, like at the end of the day, this might be like a USB stick. So something an attacker can actually insert. And it also has like a set of interfaces here. So yeah, you can fuzz both sides. You can fuzz both this side, and you can fuzz this side, this interface. assuming you are fuzzing this interface here, well, you can still do genetic fuzzing even if you do not have a source code. One way to do it, I guess, is to run. There are two ways to do it. Well, how people do it. Either you run the full system or like a thinned down system on an emulator, and you are just fuzzing that device driver. You are passing data to it, and and you are just interacting with it, and you are measuring the code coverage here somehow. It's complicated, but you can do it, especially if you have an emulator. That's easier than on most stuff. And yeah, that's basically it. If it crashes like blue screens, you need to somehow notify your fuzzer, like, you know, the harn, not really the harn, it's like the part which is making sure that fuzzing is still going on. You need to somehow notify it that it crashed and what input crashed it, and yeah, that's it. That is one approach. The other approach is kind of crazy, is to actually take the driver and rip it out of a kernel and port it to userland. This is complicated. I know great researchers that have done it. I didn't do it myself. I started, but then something like, yeah, I had to do some other stuff, so never finished that one. But yeah, and you can basically do it. If you can rip it out of a kernel, you can port it to a userland, and then you have a userland application which you fuzz normally. It will still crash, it will not cause a blue screen anymore, but it will still crash, so this is the second way you can do it. And this is kind of the same with a device. You can like have a real computer, like, I don't know, just get a computer for $100 or whatnot, or even cheaper, like an old one. Install the operating system, put all your harness and everything there, and have a different device which is basically interacting with the driver and try to crash it. Like, for example, send some weird USB replies to the host. Another way is to have everything on an emulator and this device to be emulated. It kind of gets complicated because this isn't like this, really. Like, my drawings are terrible, but it was still super easy. It's usually like this, that you have this driver, but this driver is communicating with this driver, and this driver is communicating with this driver. This is like, for example, I don't know, like a special USB device driver. This is like a general USB device driver, which is communicating to a USB chipset, like UHCI or whatever, or XHCI. And this is communicating with like the PCI Express driver. And this is communicating with like some HAL, hardware abstraction layer. And this is communicating with PCI Express bus, master, whatever, bus device. This is communicating to the USB chipset like UHCI, XHCI, or whatever. And only this is then communicating with a switch, like a USB hub, and only this is communicating with the device you actually attach there. So it's kind of more complicated, and if you have like no luck, or if you have luck, depending on the perspective, you might get a crash on a chip, right? Or you might get like, you might enter a state with this was not foreseen and was not tested for. Or you might crash like some other driver, which is also fine. So yeah, when fuzzing from a device, you need to be aware that there is like a huge chain, a huge stack of devices which you are fuzzing. You are not fuzzing with one separate device. If you want, you can just try to cut here and instead like port it to user mode, cut here and interact with it here and fuzz from here. That's also possible to do. Yeah, that's ends the long answer, I guess. Is there, I'm sorry, Ibrahim writes, is there any books that you recommend for TSR programming? What do you mean by TSR? I know TSR as terminate and stay resistant, but that's probably not what you mean, because that was a technique under Microsoft DOS, which was what, 30 years ago, to basically have programs running in the background, which on DOS was weird because DOS was a single process operating system. You could have only one single process running, so having something in the background was pretty unusual. So yeah, Ibrahim, I'm sorry, I just do not fully understand the question. I am going to look up what TSR is. Okay, Television, Swiss or Manda, that's probably not it. TSR programming. No, Wikipedia says terminate and stay resistant. That's it. Yeah, just feel free to catch me on Discord if you have any questions later. Yeah, I'm checking my Discord all the time. And again, just feel free to go to Genveil Live, EN, and there is this Discord. Well, Discord is here basically. And the address again of our website is genveil.live. Cool. That's it. Let's finish for today. Thank you for being here. Thank you to Foxtrot Charlie for being my moderator today. Yeah, this person here, thank you very much. Thank you to all of you for being here with me and suffering with me when parsing the code from really a long time ago. I will see you next week probably. Again, we'll probably do Hack the Box, we'll see. And then in a couple of weeks we'll get back to the topic. So that's it. I'm going to leave you with some music. Thank you, see you, take care, and be well. Bye bye.